做旁边早点走。进来吧，进到了，哇，你的小孩给我赶紧走。哪有。然后老师一看说，可以，为什么？因为表上只签了你一个人的名字。我记住了。你现在这个确实有点少。哎，不少啊！大一之前一点的素质已经很低了，大一这个时候早都挺低。我刚才看。大一啊，大一那会儿上来是期中考试以后哪有这个？大一出来，我没上过，基本全上了2回。基本上大一考试，像我有拿1的学位。教学委有个屁，我在瞎说。打不到路的就是在一起啊，谁觉得说1等学位没有最高的真的是太难了。你看打不到最高纪念品，健身你开大招带1呼，那个再加急走，再加那个闪现，你知道吗？我靠，逃命1流，可怕。这是有2吗？我早就可以了，我也是20几岁了，我就你说像我你是包括还全都增加了，包括增加了。这是我2幺，我大肚子叫，我就准备要说这个词。我大肚子叫我大肚子叫孩子们，是字儿。我小时候就讲，我就知道你还有来讲没有？我有印象，在文革的时候撒一把词，大家看哪一个？我就指嘛，这是什么并不会被逼的是吧？但是我就觉得在家长这方面的话，做了8件算一下这个猪的这个，年底就规划今年要上报。算一下这个猪的重量的这个 variance。你这高级很多人都会这。
Guys, could you do question 1, please? On sheet 5. You guys are okay?
所以你是先变黑了，只要是距离这个还是时光都外强，还有点。
Yeah, the smaller the value for alpha and beta so the smaller the alpha, the better the test. The smaller the beta, the better the test. Yes, so you want alpha and beta to be as small as possible. That's the idea. So you should plot the cover function. You should look like if you look back at the notes, you will see it. I talked about it last Wednesday in the lecture. Yeah. You should be as close as possible to the horizontal line. Ideal function is one everywhere. This is the ideal but you cannot get the idea. So what you can do is you can have a power function that's looking like this. And get the power function by the NP test. Then you can give test, this is the best you can get. In other words, you cannot have any function so you will have to
告诉你，将来我塔跟人解放军，解放军大陆我就是会飞得走。
Yes, either this one or this one. Yeah. You just need to do more examples, man, on power function. So you know what's happening. So try question 1. Guys, can you do question 1, guys, please? Is this too bright, guys? Is it too bright? Yeah? Yes? Can you see it from there? No? it okay now? Alright guys, so let me show you, let me show you how to do question 1 guys. You're testing this versus this, where P is the proportion of defectives and Y denotes the number of defectives in a bag of 20, right? Now the question is to find the power function at P, right, which is the probability of rejecting H0 given the value for P. Now you should read the question guys. It says you got the sheet in, everybody has a copy of the sheet? Yeah, what does it say? We reject H0 if what? Read the question guys, please. Y greater than or equal to 7 or less than or equal to 1. Yeah. Now I'm going to use the complement rule. Now what's the complement of this guys? The complement of this event is if Y is between 2 and 6. Yeah. Right. The complement of this event. Right. Now if Y is between 2 and 6 guys, then Y can take the values from 2 to 6. Yeah. 2, 3, 4, 5, and 6. Now, can you tell me about the distribution of Y? Remember, Y represents the number of defectives in a bag of 20. You have 20 items in a bag. Some of them are defective, some of them are not defective. And Y is the number of defectives. So what distribution will it have? Binomial, yeah, exactly. So you have a binomial distribution with parameters 20 and P. So it will be, so the probability that Y equal to you're done. So this is the power function guys, right? So the power function is 1 minus this thing here. Now you are also asked to find the value of the power function at these values for P. So what you need to do guys, I'm not going to do this here now, but you just need to sub in these values into this formula and work them out. So you need a calculator for that. Obviously I don't have that with me. Now finally, the significance level. Now remember what I said during the lecture today. The significance level is the same as what? What did I say in the lecture?
Probability of
Type 1 error, exactly. It's the probability of type 1 error. And the probability of type 1 error is simply pi at 0.2. Because remember, P is equal to 0.2 under the null hypothesis. So the probability of type 1 error is simply the value of the function, value of this function at P equal to 0.2. So that's it, guys. Right? I'll let you guys do the calculations because I don't have the calculator with me. Can you do number 2, please, now? Question 2. How are you, sir? You alright, sir? How are you, sir? You alright? How you guys doing? You okay? Oh, everything okay? Anybody who hasn't signed, they have the sheet. You guys all right? Have you guys done question 2 yet? No?
Yeah.
You have? Good, very good.
You reject h0 what? If x is what? I can't. X is less than or equal to 5, right? Yeah. So what we want to find, guys, is we want to find the probability of type 1 error first. So which is the probability of rejecting h0. Come on, this pen is not working. Oh, come on. What's wrong with my pens? None of them work. Sorry. It's the probability of rejecting h0 given that h0 is true, that is p equal to 0.1. Okay? So this is the probability that x is less than or equal to 5 given p equal to 0.1. So it's the probability that if x is less than or equal to 5, guys, then x can be, sorry, this is 0.1, guys. X can be from either 1, 2 up to 5. So 1, 2, 3, 4 up to 5. All right. Now we are told that x is a geometric variable, right? You guys remember a geometric distribution, right? Which is, if you look back in the lecture notes, guys, you will see where it is. This is stuff we did in week 1, I think, week 1 of classes. This is the probability mass function of the geometric distribution. Yeah. So this is the answer for the first part. The answer for the second part is this is the probability of accepting h0 when h1 is true. Yeah. So is 1 minus the probability of rejecting h0 when h1 is true, and this is 1 minus the probability that x is less than or equal to 5 given p equal to 0.2, and this is 1 minus the probability that right, and this is 1 minus yeah. Alright, so that's the answer, guys. Alright, so this is the probability of type 2 error, and this one is the probability of type 1 error. Okay, are you guys with me or not? Yeah, it's easy, right? Alright, can you do question 3 now, please? Your answer? Yes. Yeah, you can do that.
Yeah. It's the same answer. This will be the same as that when you work it out. When you work this out, it will be the same. Yeah, if you work it out, it will be the same. Yeah. Do you have any questions? Are you okay? Alright, sir, you're right. For question 3, you need to use the election odds, guys. You need to use the election odds, guys. If you don't have a copy, I have it spares with me. You need a copy? Yeah. You need to use the notes. Yeah, right. You need to use the stuff I did this afternoon in the lecture. Good question 3.
All right, can you tell me the rejection rule looking at the lecture notes, guys? This is stuff I did just in the lecture from 4 to 5. You guys were in the lecture, right, from 4 to 5. So you should know the answer to this question. Reject H0 if come on, guys. If what? Yeah? Come on, look at the stuff I taught you guys. I just taught you this stuff just a few minutes ago. Just look at look at what I taught you guys. It's in the lecture notes also. What? Yeah. Root n divided by do you know where this comes from, guys? This is it's equation 95 in the lecture notes, I think. Yeah? Yeah? So, now the question, guys, is to find an expression for the probability of type 2 error. So we want to find the probability that of accepting the null hypothesis when H1 is true. So in other words, the probability that root n by 2 times this is less than or equal to this. Yeah? Now, alright, now I've done this many times already, guys. Now what's the next step I should do? I've done this enough times, I think. Standardize, exactly. Right? Now, we know that the true mean, this is where I'm going to use the x bar. This is the result I'm going to use, guys, right? So to standardize, I'm going to use this result, guys. So I'm going to subtract the true mean, which is 4, and add 4. Okay? And then I'm going to take this 4 here to the right hand side. So that becomes right. Now this guy here, because of this guy here has the standard normal distribution, right? So what you have is the probability that n01 is less than or equal to. Now I don't need this condition. Remember, the conditioning disappears because I'm using the conditioning. I have used the conditioning to argue that this has the standard normal distribution. So we don't need the conditioning anymore. All right. So the answer is phi at all right, so that's the, so this is the expression for the probability of type 2 error. Yeah? You guys okay? Or your answer? Yeah, okay. anybody has questions, guys, feel free to ask me. Can you do question 4, please? Question 4. You right, sir? Good. This is a two-sided test where you have mu naught equal to mu 0. And this is one side where mu is greater than mu 0. So the rules are also different. Yeah, you can't use this one. Well, you can use both, but I think it would be better if you use this one because under the alternator mu equal to 4, which is greater than 0. So it's better to use this one than this one. Yeah, it doesn't matter because it's a confidence variable. So less than less than. Yeah, in the grand you get the same mark. It doesn't matter where you write. Yes, no, if I is between 0 and 4 and you close it, then it must be 5 over 100 because I can make 3 numbers from 0 and 99 to 100 and 0 and 4 are 5 numbers. So 5 over 100. It's the same method, yeah. Yeah, it's just that the procedure for I doesn't depend on mu. So it doesn't matter what mu is, the answer is always the same. Yeah. And you do question 4, please, guys. Question 4 is similar, guys. No, I think you're confused because when I said what is this number, is it 0.025 or 0.05? Or 0.0. Yeah, okay. Yeah, so what can I use the pen? Right, okay. So when I write like chi squared what I mean is the following. I mean actually alpha is the area to the right. This area here is alpha. Right? So this point is pi squared m minus 1 alpha. Yeah. Whereas this table, I think it gives the area to the left. You have to be careful when you read this table. You know what I'm saying? So for example, if this is when you read this for me, well, this is it point 0.05. That means we should look for point 95 in this table. So you should look for point 95, not 0.05, because 0.05 is this area. Whereas this table here gives you the left area. If this is 0.05, then this area will be 0.95. So you should look for 0.95. I know it's kind of confusing, but that's the way I define it. Throughout the lecture notes, I always define the right area to be alpha. Even this table, but when you read it, you should always take one off from this one. So when you read for point 0.05, you should look for 1 minus this, which is 0.95. Yeah. Yeah, it's the same for other distributions too. Yeah. Same for the yeah, it's the same for F and the T and the normal and all the other distributions. Yeah, 1 minus. Yeah. Alright, and you guys got question 4, guys? Let me, I've got only a couple of minutes, 5 minutes left. let me show you how to do this. Guys, could you listen please? In this case, what's the rejection rule, guys? For testing this versus this, the rejection rule will be root of n by 2 times x bar in modulus greater than z alpha by 2. Right? Do you see this from the lecture notes, guys? Yes? Can you see where this comes from? Yeah? Okay. Now the question, guys, is to find the power function at mu. So this is the probability of rejecting, which is the probability of rejecting given the value for mu. Now first thing you must do, I think I already did a similar question in the lecture this afternoon. The first thing you must do is to remove the absolute sign. So I'm going to do that. Alright, this is the first thing you must do. Alright, the second thing you must do is to do the standardization, right? To do the standardization, and I've done this enough times, guys. So because the true population mean is mu, I'm going to subtract mu and add a mu. Right, this is what you get, guys, right? Right, now the next step, I'm going to move this to this side. I'm going to move this to this side. So that will give you All right. In the next step, I'm going to use the fact that these two guys, this one and this one, right, because of the standardization, these two will have this standard normal distribution, right? Right. So, and right, you see here I have removed the conditioning because I have used the conditioning to argue that these two guys have the standard normal distribution. So we don't need it anymore. We don't need the conditioning anymore. So, all right. And in the final step, I'm going to, because these two events are mutually exclusive, we can write this as yeah. And you can also if you need one more step, you can write this in terms of phi, the phi function, right? This is all right. So that's the this is the power function for question 4. Alright. Alright guys, are you okay with this? Anybody? Yes? Alright guys, I'll see you guys tomorrow. Alright, if you have any questions, see me in it. Just try to spend more time on this course guys, because the midterm is going to come soon. Well, not too far away. Alright. Alright. Okay. Yeah, no relation yet. Yeah. I has no relation to mu. So I'm saying the same. It doesn't matter what mu is, it's the same.
为啥？他们老穿那种颜值最高的，老穿那种花衬衫，然后戴个吊带儿，就这种就一人说，就是稍微再高一点的话，不，就是稍微再没那么胖一点，再好就是矮，再高一点再帅的就有些一人讲特别有，这样不让我睡着。靠点，这家不买。
靠你自家预测，真的是没来谁预测错了，别人那是。别
你们怎么一天到晚的哇？是我看见的。还好我没有见过这个，我见到我也不会说。错。这是脸，这是他的眉毛感，这个才是，这个而且脸，他的脸是纵欲过度。算我带上。纵欲过度，还是带了嘛？我觉得他是纵欲过度。
你是指他耳朵？
怎么连他？
我也是个耳朵，我是在跟你讲过的。
耳朵。
亲个耳朵。什么呀？你耳朵亲吻？我没有啊。这哥们儿又听着了，这哥们儿我操，随机插入。
耳朵。没有，我走了。
拜拜。
有还是没有？
这个可以啊。干嘛呢？搞脊椎不好，对不？对，我去。让回我。
那就可以投票了。我操，太屌了！哎，西卡怎么了？
没有，他现在就是不来。
不想。
我操！
注意，第一个字的读音啊。
操劳过度。
操劳过度。直到所有人。怎么你还在写啊？我在看他写啥呢？
疯了。
其实我不是很爽。根号20是2倍根号，所以上面根号5，那不是2减1.6。
为啥不拿这个看
1.645是啥呀？1.645是啥呀
？1.645看表。
1.645是那个啥
？90%。
95。
就是这个东西吧？就这个东西吧？
看不清楚吗？
在。
在。